Question 1. A, B, C have these coordinates. L passes through C, perpendicular to AB. So I've sketched that already. A, B, C. The line L is perpendicular to AB and passes through the point C. So the first part of the question then, find the gradient of AB. So the gradient of AB is equal to A, increase in Y, 3 to 0 is minus 3, divided by the increase in X, minus 7 to 2 is 9, so that's minus 1/3. Okay, show that the equation of AB is this. So let's do part 2. Y minus the Y coordinate A, say, is 3, is equal to the gradient. X minus the X coordinate, minus 7. So move the 3 up, minus, and run the minus through the bracket. And then we end up with X, move the X over here, plus 3Y. Move that, we get minus 2, don't we? X plus 3Y minus 2 equals 0. Find the equation of L. Okay, so part 3. So L is perpendicular, and it goes through the point C. So the gradient of L must be 3, mustn't it? Because it's perpendicular, the product is minus 1, so 3 times minus 1/3 is minus 1. So Y minus the Y coordinate is equal to the gradient of L, which would be 3, X minus the X coordinate minus 3. So we end up with then Y minus 5 equals 3X plus 9. So that tells us that 3X minus Y plus 5 and 9 is 14, and then it's equal to 0 over here. And I've written it from right to left and move these two things over the other side. So that was part 3. Okay, the line L intersects AB at the point D. Show that the coordinates of D are this. So when do the two lines intersect, basically? Is what it's asking. So let's have a look at that. When do these two lines intersect? 1 and 2. So if we do 3 times 1, 3 of these, 3 of all things is that, and we've got this. So that would be number 2, wouldn't it? So we'll do 3 take 2. Looks easiest, doesn't it, that way round? Because that way these will cancel and we get 10Y. Minus 6 minus 14 is minus 20. So Y will equal, 10Y is 20, so Y equals 2, to cut a long story short. If Y equals 2, move this over there. So we get Y is equal to 3X plus the 14, isn't it? Oh, that was Y equals 2. So we want X, don't we? We'll get it from here. So let's just scratch that. We don't want Y. We've already got Y. We want X. So here X will equal. Move the 2 over and the 3Y over. So it's 2 minus 3Y is equal to 2 minus 3 times 2 is 6 minus 4. So D has coordinates minus 4, 2, which is what we've shown. Show that L is not the perpendicular bisector of AB and find the tan. So L is not the perpendicular bisector. Well, it's perpendicular, but is it the bisector? So for that we want the midpoint of AB. Okay, let's get the midpoint of AB then. Minus 7 plus 2 is 5 over 2, and then 3 and 0 is 3 over 2. So it's 5 over 2 and 3 over 2. 5 over 2 and 3 over 2. And that is not the point D. So we've done C, haven't we? That is not the bisector. Part D. Part D. Find the value of tan ABC. Give your answer in its simplest form. Tan ABC. Well, what have we got in our picture then? We've got this coordinate here is D. We've got a triangle, so we've got a right-angled triangle. This is the D, which was what coordinates? Minus 4, 2. So the length of CD, using Pythag. This is the opposite side. We want the opposite over the adjacent for this tangent of this angle, CBD. So this side length will be, using Pythag, minus 3 to 4, the difference is 1, so it's 1 squared. And we've got 5 to 2, the difference is 3, so it's 9, 3 squared, which is 9, so we get root 10. And this distance D to B, now B has coordinates 2, 0. So D to B, minus 4 to 2 is 6. So this is BD now, using Pythag. Minus 4 to 2 is 6, so that's 6 squared. And 2 to down to 0 is 2 squared. 36 and 4 is root 40, which is 2 root 10, isn't it? Root 4 times root 10, which is 2 root 10. So tan is the opposite over the adjacent, so it'll be root 10 over 2 root 10. So tan of the angle in question, ABC, ABC. So tan of ABC then, which is this angle here, is the same as the angle in the triangle, which is opposite over adjacent, which is root 10 over 2 root 10. Root 10 over 2 root 10, which is a half.